Hello everyone, welcome to our presentation. The presentation is about our latest work on ICCV 2021, end-to-end trainable Trident person search network using adaptive gradient propagation. This is our contents. First of all, person search is the task that combines person detection and re-identification. When the detection and re-ID network is separately trained without any shared parameters, we call it two-step framework. On the other hand, when two tasks is jointly trained, we call it end-to-end framework. Comparing to two-step framework, it saves the training parameters, and we can utilize the detection information on the re-ID network at the training time. So we choose the end-to-end framework. However, training two tasks simultaneously has problem. Person detection network tries to embedding the features based on person commoness. On the other hand, person re-identification embed the features of person uniqueness, which is exactly contrary purpose. So, training with balance of these two different tasks is challenging problem in person search. For example, at the early phase, because the person is not exactly detected, the network is training for person detection. But person re-identification is trained with wrong bounding boxes, which breaks the balance. Another problem is existing two tasks, detection and re-ID, are not enough to embedding fine-grained local features, such as accessories and clauses with pattern. This is overall architecture of proposed method. Like Redbox, we introduced the new third-party task path classification, which embeds fine-grained local features. And like Blue Arrow, we make a connection to balance of multitasks by controlling the gradient. The proposed path classification prevents the overfitting of person detection or re-ID with multitask learning manners. The part classification predicts each human body part without any manually annotated labels, and encourages the network to embed the fine-grained local features. And then, we control the re-ID and part classification gradient by proposed adaptive gradient weighting function. We define function f, which controls the gradient of network outputs. But the function always has same shape, even the bounding box does not enough include the persons. So, we reflect the confidence of detected bounding box. By multiplying detection confidence, the shape of the function is adaptively changed. The new function is called AGWF. The sensitivity of AGWF is decided by how much bounding box includes the person. We evaluate the detection and re-ID performance with two benchmark datasets, GHKSYSU and PRW. The table shows the effectiveness of the proposed method. With multitask learning manner and by alleviating the task conflict, the part classification and AGWF has gained as tables for detection and re-ID performance. Comparing to the existing end-to-end methods, the proposed method shows the state-of-the-art performance for two benchmark datasets, and qualitative comparison shows that the proposed method extracts fine-grained local features well than existing method NA and HOIM. This is our conclusion. The person search has problems of task conflict and exploiting fine-grained local features. The proposed AGWF and part classification alleviate the task conflict and embed the fine-grained local features. Experimental results show that the proposed method reached the state-of-the-art performance. This is the end of our presentation. Thanks for your attention.